Alright, so 45, 45, 90 is half of a square. The other half looks just like this, kind of. And now they give us this, so we also know y. Y's got to be 3 square roots of 2. All the way around is 3 square roots of 2. Now the diagonal, the hypotenuse, is going to be 3 square roots of 2 times the square root of 2. So it's going to be 3 square roots of 4, which is 3 times 2. So x should be 6. Solve each triangle. They want to know angle A, angle B, angle C, and then side A, side B, side C. So we know angle C is 90 degrees, angle A is 24 degrees. So if we take, there's 180 in a triangle, but because we know we're already using 90 plus 90 is 180. So there's another 90 left. So 90 take away 24 degrees is going to give us 66 degrees. So angle B's got to be 66. Okay, now we know side A is opposite of angle A. So this is side A, this is side B, this is side C. Side A is 5. And the only way we're going to figure out side B or side C is if we use some trig. So I am going to label this triangle as if I'm looking from side or angle A. So if I am looking at angle A, this is going to be my hypotenuse, this will be my adjacent, and this is going to be my opposite. Okay, now I am going to find the hypotenuse. I'm going to find C. So C is the hypotenuse, and I'm going to use 5, which is opposite. So which trig fraction uses hypotenuse and opposite? It's going to be sine. So sine of 24 degrees equals opposite over hypotenuse. And from here on out, it's going to be calculator. So I need to solve for x. When x is in the bottom of the fraction, you got to get rid of it. You got to move it to the top of the fraction. So I'm going to multiply this side by x. So I'm going to do the opposite of divide by x. I'm going to times this side by x. I'm going to times this side by x. Divide by x times by x, that undoes itself. So now I got x times sine of 24 degrees is equal to 5. And now I'm just going to solve for x. So I'm going to divide this side by sine of 24. Divide this side by sine of 24. And I have to make sure my calculator is in degrees. And if your calculator is in degrees, just punch in 5 divided by sine of 24. And it's going to give you probably some ugly decimal, so we'll just round it to a couple decimal spots. And I'm going to get, that is going to be 12.29. Now one to go. If I know this is 12.29, let me erase this. Now we can find, I'm going to do the same thing, except I'm going to use, now I can use cosine. I can use cosine of 24 degrees, and that is going to give me the adjacent, which is what I'm looking for. I'll call that x, over the hypotenuse. I now know the hypotenuse is 12.29. Okay, now this one's easy because what I'm looking for is on top of the fraction. So I'm going to solve for x. I'm going to ditch this 12.29. So I'm going to times this by 12.29. Times this side by 12.29. And x will give me 12.29 times cosine of 24. 12.29. Let's see. times the cosine of 24 degrees. And that gives me 11.23. So there's all three angles, all three sides, rounded to the nearest hundredth, and we are in business. Okay, this one, I need to find angle A, angle B, angle C, side A, side B, side C. But now they have given me side B is 6, side C is 14, and I know angle C is 90 degrees. So this one, if I know two sides of a right triangle, I can always use Pythagorean Theorem. A squared plus B squared is C squared. And C is the hypotenuse. That's 14. I know this is my hypotenuse. And so I can set it up like this. 6 squared plus x squared equals 14 squared. So x squared is going to be 14 squared minus 6 squared. And then take the square root of that. X is going to be the square root of 14 squared minus 6 squared. So I'm going to punch that in on my calculator. Let's see, square root of 14 squared minus 36. And that gives me a decimal. It's 12.65. So if we call this side right here 12.65, that is side A. So 12.65. Okay, now I just gotta find an angle. And I'm gonna do the same thing. I'll just look from this angle right here. If I look from B, this is my hypotenuse, but this now becomes my opposite, and this side becomes my adjacent. And so now I gotta figure out which trig fraction I want to use. And you can use all three of them. You can use sine, cosine, or tangent, because you know all three sides, so it doesn't really matter which one you pick. So if I choose the sine of angle B, sine is going to be opposite over hypotenuse, 6 over 14. And this one's going to be a little different because I know the fraction. If I have the numerator and the denominator, I just need to solve for B. So now I'm going to do the sine inverse of 6 over 14 on my calculator and press enter, and that will give me the degrees. So inverse sine of 6 over 14, and that is 25.38 degrees. And that was angle B. I just found angle B. Oh, you know what? I labeled this wrong. 25.38 degrees. This 12.65, that's not angle A, that's side A. That should go right here, 12.65. So I'm going to erase it. To find angle A, I'm just going to do 90. Subtract my 25.38, and that will tell me how far angle A is without doing any trig, and I should get 64.62 degrees. So if you know the sides but no angles, you have to use this. You have to do the inverse sine. Alright, the perimeter of a square is 40, so draw a picture. Perimeter is the distance all the way around the square. And I know that's going to be 10, 10, 10, 10, 10, 20, 30, 40. So I add up all the sides. The diagonal is going to be 10 square roots of 2. The altitude of an equilateral triangle, so equilateral, all the sides are the same, but the altitude is how tall it is, and that's 9. So they want the perimeter. They want me to add up each side. And I know if the altitude is 9, this little guy right here is going to be 9 divided by square root of 3, which is unacceptable. So I times square root of 3 by top and bottom. So 9 square roots of 3 over 3. But 9 divided by 3, that's the same thing as 3 square roots of 3. So this little guy is 3 square roots of 3, and this little guy is 3 square roots of 3. So together they are 6 square roots of 3, and this side is 6 square roots of 3, and that side is 6 square roots of 3. So if I walk all the way around it, 6 square roots of 3 plus 6 square roots of 3 plus 6 square roots of 3 is the same as 18 square roots of 3. Okay, the hypotenuse of an isosceles right triangle. Here is my isosceles right triangle. It's half your square. So there's my 90. Isosceles, these two sides are the same. So the hypotenuse is 40. How much are these sides? And I know I went 10 times square root of 2. So now I'm going to go backwards and I'm going to go 40 divided square root of 2. So times square root of 2 on the top, times square root of 2 on bottom, 40 square root of 2 over 2. 40 divided by 2, these play together, that is 20 square roots of 2. So each side must be 20 square roots of 2. Is that it? Are we done? Okay, I think that is